Okay, then let's start with SPM programming. You might have realized that there is no video from last session, which is due to the fact that not only did the computer crash and was really slow, but also the video capture crashed. So actually the video does not exist. But then there was not really that much happening. We just downloaded SPM and downloaded the data. And this is where we start from now. So so today I'm not, maybe actually also completely disconnect. So this whole thing does not sync today, so it should run smoother. So what we got up to was essentially to create a folder which has the SPM toolbox, which we downloaded last time and looked a little bit at, and have a data folder where we have the data from one participant, and we downloaded the PAREC data, which is the MRI data, and we discussed that, for example, by the file size you can tell what's going on. So we have here these runs 4, 5, 6, 8, and 9, which are functional data. So ideally, of course, this is digitally documented and is also a nice exercise for your data science paper / project report / I don't know what you want to call it. And we downloaded the behavioral data which we need for the onsets. So that's the setup. And now we just start. And the first thing I want to show you is how to create scripts in SPM, because that has really simplified a lot. So in the old days, what you needed to do to write scripts is for SPM is actually there's actually an SPM bits function. You might want to look into that if you're thinking about bitsing. You needed to know what the SPM functions do, and then write basically wrapper functions for SPM functions that do, for example, pre-processing or GLM functions. And these scripts exist. So you would, for example, if you want to set up an FMI design, you would basically specify the inputs for such a function like SPM FMI design. And you need to study what these different things are that you put in. And off you went, but that really needed quite some expertise in terms of knowing what the SPM functions actually do. This, however, has simplified a lot in terms of creating SPM scripts since the introduction of the SPM batch editor, or the SPM batch, or whatever you want to call it. And so this was an add-on that is now fairly integrated into the whole SPM package. An add-on not written by the SPM people, but by, I think, people in Freiburg, which eases actually dealing with SPM at the level of the GUI, but much more importantly, for the purposes of reproducible science, allows to basically turn GUI batch commands into scripts fairly straightforwardly. So you can basically now interact with SPM in a nice way at a very high level, where you don't need to go into all the details of the SPM functions, but you can still script it and you still know roughly what's going on. So let's see, actually it wanted me not to add the subfolders. So to show you what I mean by this, we will now first go through the GUI with the aim of importing one of these PAREC files, which of course you need to do because PAREC is not the standard format that is used for SPM analysis. This format is nifty these days. It used to be this header and image format, but I think the common data format for FMI data analysis now is nifty. So let's do that, and you know that you start SPM from the command window. If you specify EEG or something else, then you that didn't allow me to do that. This is why I did it. No, it complains. Anyway, so if you specify FMI, you don't have to go through this nice initial screen. Then SPM is initializing. Wonder whether this recording and doing computational stuff at the same time is that good. But at least we get here. And then to access the batch editor, which also allows you to simply write scripts, especially if you're starting with a script writing from scratch, is here very prominently. It's the first thing that you see if you look at the interface, of course. So you can essentially ignore all of this, because all of these buttons that you see here you can also access via the batch interface. This is the batch interface, or the batch editor. And also, very straightforwardly, of course, the things that you want to do is if you go to SPM, and then you can see that you can do many things. So for example, in terms of fMRI preprocessing, you can do slice timing, spatial preprocessing SPM, you can do realignment, correlation, segmentation, normalizing, and smoothing. In terms of statistical analysis, you can specify fMRI models, review models, and so on. And all of these things are now in the batch editor, so that you can actually save batches and scripts. What the difference is, I will tell you in a second. You can also do some DCM stuff. You can also do EEG now. This actually is the latest, or at least from my perspective, the latest addition. So there was a time where you could do the fMRI analysis from the batch editor, but the EEG analysis not. Now you can also do the EEG analysis, and a number of utilities and some other tools, like, for example, old versions. I think not every SPM functionality is incorporated into the batch editor yet, but it's getting more and more. What we want to do is import, and we want to import parallel files, because that's what we want to do. Then this is the common thing of this batch editor. You get essentially this window where you need to specify certain things. So of course, if you don't tell a software what should be imported, or basically transformed into another format, then the software doesn't know what it should do. So you need to specify something. It will not just magically do something. You need to tell what to do, although it's of course artificial intelligence, but you still need to do what to do. And this then looks like this in this X. That means you need to specify something. This whole GUI thing is a little bit annoying, and it's weird, and I hardly use it. So right click sometimes is helpful if you want to delete things. That's something to know, and otherwise it's just weird GUI interface. But nevertheless, let's select now one parrec. So let's use this fourth one. And then you need to click on done. So the parrec files always go together. So we just need to specify the parameter file, and you need to specify where you want to have it. So maybe to that purpose, let's for the moment create another folder in here. So let's, how do we do that? so actually for the for SPM analysis, bits does not apply that much, because bits, so the standardization, this really refers to the raw format. Everything else that you do with this raw format then actually is something that is not in bits and is what is called derivatives. And there you can again go synchronously, but you can also try to follow bits in this regard. So I'm now following not bit stuff, because as discussed, we do bits after we did this. So then you need to basically tell where to put the transform file. And this is again with this a little bit weird interface. It's always, it puts things here. You can get rid of them by clicking on them for whatever reason, but you can, now nothing works anymore. Where is it? There. Now it's there again, and when you're done, you click done. So two things are important now. So this is how you go through this GUI, and you should avoid going through the GUI and only in the first, when you first set up scripts for something, then you it makes sense to go through this. Otherwise, you should not do it, because it's just annoying and you get crazy. But two things are important. If this is green, this little arrow here, that means everything is specified and the batch is ready to run. If it's not green, then there's still things open. So in principle, we could run it now, and we will run it in a second. But first, and this is the most important thing for interacting with SPM and reproducible science, you can save the whole thing as a script. Actually, this button is wrong. I don't know why they still haven't corrected it. You can save it as a batch. What does that mean? Let's do that. Let's save what we've done here as a batch. Maybe we do a new folder here, which we call pre, where we save, now let's call that CB import, CB for checkerboard. Can save that as a batch. So what does that mean? What this saves is a file in which you have a structure which is called MATLAB batch. It's not a MATLAB thing, it's an SPM thing, but it's called MATLAB batch. It's just a variable name. And you see that this is a structure. It's actually a cell, sorry, it's a cell. Let's see what I get to show a little bit of it. It's a little bit annoying. I think there's an easier way to do this, but I am holding it by hand. Import. So essentially, you see that it's a structure. Yeah. And it has saved what we just entered in there. So essentially, the file name, and then what we defined as options. So the output directory and the extension nifty. We could have changed that. That was one of the default. That is what they call a batch. But this is a file which just saves the parameters that we've just entered. That's good for reproducibility. You can also load these things, and then at least it's saved what you've done. But it's not really awesome. What is even more helpful is save batch and script. And this is a lie from my perspective, because it only saves scripts and not a batch. So let's save this now, because we are doing our scripts in our data analysis folder. Let's save this for the moment under the name import. And then it actually saves two things, and this is, I think, why it calls it save batch and script, but it actually saves two scripts, in the sense that this other thing that you save is not a script, so it cannot be the same thing. It's either a file, a MAT file with some values in it, or it's a script. So this name in the SPM menu is wrong. But we have saved some scripts now, and these scripts are important. So one thing is this, and the other one is this. So this, which we call import, this I think I want to leave it at this size, uses what is called SPM jobman to run a job. Yeah. So here SPM jobman, and SPM jobman is actually the function that we want to use extensively for SPM programming. So let's have a look. So here you find some ideas about this. So it's the main interface for SPM batch system. It needs inputs, and then you can read all about it, as I said. So this is actually not written by the SPM people, but from people here from Freiburg. As I said, the documentation of SPM is in the head files, which is somewhat annoying because you rather would have a nice handbook that explains these things. But there's I think there is some explanation in the manual, but the most extensive explanation is still in there. Now, what does this SPM jobman do? Well, it runs jobs. So, and this is the only thing that's happening in this import script. So it specifies a job file, which is this other file that we will look at in a second. Then it actually creates this as input for SPM jobman. The important thing is this job file. So this is really the important thing. So what this is just the specification of the structure that we just looked at in script form. Yeah? So it defines a structure called MATLAB batch and defines certain fields. And then this structure is passed to SPM jobman, and SPM jobman then interfaces the specification of this job file with the SPM more downstream or low-level functionality. Yeah, so the important thing is to specify these jobs correctly. Actually, if this is not done correctly, the whole thing will not run, it will crash. This is usually when you start doing your scripts, you will get paths wrong, and then it doesn't find files, and then it doesn't run, and then you have to fiddle with the files, as we will also do. Yeah. But the same logic that I've just shown you for import applies to all the SPM functionality that is integrated into the SPM batch. Let's see when I find my windows again here. So everything that you can call from here, for example, model estimation, you can go via the GUI and create a script from it. Yeah? Or you can, if you want to reorient an image, you can through the GUI and create a script from it. So this allows you really to create scripts very easily without actually going into the details of the SPM functions. And you have also the guarantee that they run if you specify the fields correctly. So this is how the fMRI scripts that you have as examples are generated. And also, I think the EEG scripts. For some time, I had EEG scripts that didn't use the batch system, but then, of course, as soon as this got into there, I also standardized them according to this. So the bottom line is writing scripts for SPM these days is easy. That's good. It's high level. That's debatable whether that's good, because it means that you only know what's going on at the high level and not at the low level. So essentially you can use, and of course, and this is also sometimes what people get a little bit misunderstand me, I'm against toolbox culture, but when I mean what I mean more specifically by this is not trying to understand what the toolbox is doing. But of course, you will always use toolboxes. I mean, just using MATLAB is using a toolbox, or using NumPy and Python is using a toolbox. So, and there's no point if you want to do some numerical computing in Python to not use NumPy because you don't want to use it in toolbox. I mean, you can, but then you will not get anything done until you die, and that's then a little bit too late. So, interacting at this high level is, from my point, okay. The good thing is that you can script things. So you document in detail every step, every thing that you did that deviates from the defaults, or just also the defaults that you did, and somebody else who roughly in the time frame of when you did this, of course in, I don't know, 10 or 20 years, the scripts that you write now, if SPM ever develops further, who knows, will not be applicable anymore, like the scripts that I had during my PhD. I don't think they run anymore, but this is at least, this is why you have now things like Docker and things, so that you take snapshot of the whole thing. And what is also important, that you save the whole SPM version when you share your scripts, so that the scripts that you develop apply to the SPM version, that then also your fellow research worker has to reproduce what you did. Yeah. So that's all very simple, and you all knew that, I assume. Did you know that? No. Do you care? Good. Also not really, but anyway. Good. Then we can now, just for the fun of it, run this import from the batch. Then you get this nice little warning that you use this at your own risk, but you live your life on your own risk, so we can deal with that. And then it's doing its thing. If it's busy, you can actually see that. Shouldn't take that long. I think it's already done. And if we go, see what it is. Yeah. So it creates a single Nifty file. We actually have to split this up into multiple files later on. But so now we have imported the PyRec file for this run. And now that's fine. And if we would be, I don't know, master students in a bad lab, we would now continue. We have imported it, so let's continue to the splitting it up and realigning. But we are not master students in a bad lab. We are master students in a good lab, which means that we write scripts and we take care of putting what we just did, kind of GUI thingy. We put this into a script so that everything is nice and in order, and my compulsive obsessive disorder cravings are satisfied. This is what you get for these kind of comments. Good. So, so the aim is now to actually write this import into a script, and we have what we need for it. So we have, we know how to call that. We also actually have old scripts that were created in the same way because I shared them with you. And based on this, we now write a script for FMI pre-processing, which in its first step imports the data. Yeah? And all the other stuff that we also do in pre-processing, splitting the Nifty file up, realigning, smoothing, we do once we've scripted this. We go step by step and write clean code on every step, because currently all the PhD students that I work with, they somehow get to the end of their project and then I think we're done, and then it turns out they have written a lot of messy code, and then there's it's another 3 months or so where they start cleaning up their code. Although I told them in the very beginning, write clean, nicely documented and understandable shareable code from the outside, but somehow it seems to be hard, even if people explicitly encourage that. For me, it was hard in the very first lab that I worked in, because my supervisor was all the time, what are you doing? Give me the results. I need the results now. You cannot work in this kind of environment. But then once I left the lab, because I cannot work in such environments, I started to write clean code. I mean, maybe my code is cleaner now, but you can also do that as a PhD student, and you should start doing it as a master student. And just do it, and if you don't do it, you just annoy yourself. If you look at your scripts sometime later, you annoy your fellow research workers. You annoy yourself when people ask, "Oh, can you give me these scripts?" And you're like, "Oh, I don't know what these scripts are doing. I don't understand them myself. No, I don't want to." And everything is just horrible fucked. So write clean, nice code from the very beginning. Always assume that you are doing this. Especially if you are paid, and in some way you are paid right now because you're getting this whole thing for free, paid for by the state, and always think that everybody who's paying you, so the whole population, watches you while you're doing this, and if you just do crap, then everybody thinks, what are you doing? Why all these contas by the Mexicans? And this is the same thing here, but you need to get this into your head. It's very important. This is open science. All the other thing like GitHub, GitHub, or I don't know, OSF is nice, but it's it's just a website where you can upload things. This is all this open science, fancy blah blah blah. Nobody is interested in that. What is important for open science is that you document and explicitly and cleanly what you do. This is important for open science and reproducible research, because then if you make errors, they are easily to discover and everybody's happy. And you know what you're doing. And you're doing work that is worth being paid for by everyone. So, now, in this spirit, let's start writing our script. Don't think I have one here already, so maybe let's also close SPM. Because of course it's still in the path. These we want, but we want a new script, which we call function. CB for checkerboard, fMRI preprocessing. Now the easy way would be that you basically start from this script and try to adapt it from scripts that you have. And this is what we will do, but we will do it in a way that is actually more meaningful, because it's not meaningful to copy and paste on a computer and then try to go over it. You should copy and paste it manually, so that it goes through your head, so that you know what you're doing. Because if you copy and paste this from digitally, then it's more annoying. And then, of course, you can still copy and paste digitally for things that are not that easy to do easily, but go in small steps. That's the most important thing. Go in small steps that you understand. Otherwise, nobody knows what's going on. And if you don't know what's going on, then nobody knows what's going on. So let's save this. CB fMRI preprocessing. And the first thing that you do when you start a new script or a new function, we discussed functions and why I always put in everything into functions in the winter term, is that you write what it's doing and what the inputs and outputs are. You might adapt this later on, but you have to write it in the very beginning, because you know, otherwise you wouldn't have started the script, what you want to do. So just write it. This function is a batch script for pre-processing fMRI data related to, to the checkerboard, this checkerboard project by Ostwald et al. 2010 neural image. I mean, the level of detail is of course a question. Try to be as detailed as you can. Can anyone give me the numbers, or can I look them up? Maybe I can look them up. cannot look it up because on this PC I don't have everything. Can anybody give me the full citation for this Ostwald 2010 paper, so just the volume and the page numbers?
We're at page 49, 2010, and then 498 to 500.
498 to 500. See, that's a long paper. It's almost 18 pages. Good. So, by Ostwald. So, of course, this will change a little bit once you have bits the data. Then it will. You might want to adapt it, but at least it's now clear, so somebody can look up this paper and then read what this is about. Pre-processing steps include, and this is based on what you know currently. So we know that we want to do parec to Nifty, which is this shortage to an NNE conversion, aka import. Then you don't know that we actually have to do this 4D to 3D conversion. That's the splitting up of files, because then we can do realignment. And then we want to do normalization, so spatial. Maybe we could also make this a little bit more explicit, because this realignment is spatial realignment and normalization is spatial normalization. And because these are spatial temporal data, one should be also more explicit about this, although these are the SPM terms. And smoothing. Yeah, so that would be a standard pre-processing, as you know. Then we specify that this function has no inputs and no outputs. Then you might want to comment that it saves data to disk, and then you want to write in there that you're the author. This is more for documentation purposes. I think there are also, if you Google, you will find that, or if you I guess also if you really set up a good Git system, there are ways to automatize, especially the things here at the end, so that you have kind of a version number automatically put in, or a date and so on. You can do all of that. It's great. I'm not doing it. And the author I'm also only putting in because in times where I didn't do it, it was later claimed that I didn't write these things by my supervisor, whose lab I left after 1.5 years. Anyway, so then the first thing is to initialize things and get started, and have a little block that does certain things. And what I always do first is that I close all figures and I clean the command window just so that things are nice. Of course, you can write a function that does these two things, but you can also put them into scripts. And then the first thing that the script needs to do is what we also did first, namely to add SPM to the path. So as I told you, I'm not a big fan of having a lot of things in the path, because then you always have have this thing that you have multiple functions that have the same name but exist in different locations and do different things. So I always suggest to have as little things as possible in your path, or if you're using Python, to import only what you really need. And according to this, this script needs to add SPM to its path. so that it can access the SPM functionalities like SPM Jobman. And this is what we do next. SPM, add SPM 12 in this case to MATLAB path. Actually, one can be a little bit more specific with respect to SPM, because what we have here is failure to communicate. Now, what we have here is a certain version of SPM, and there is a function that allows to evaluate this SPM. I think it's actually called SPM version or something. No, but we can also just look it up. Or can somebody Google, because I'm not on the internet right now, how to look at the SPM version, please, because I don't want the specific script version. Call SPM with version. Yeah, but whenever you have these kind of questions, just Google it, you will find it in no time. So this is the version that we have. What you will not find in short time is why are we using the GLM to analyze fMRI data, where you will be able to give you an answer to that. Or just answers like, yeah, you want to find regions in the brain or something. But these little things like how to determine the SPM version, that's what you find on the web. So we want to add SPM 12 to MATLAB path. If you don't know how to do that, Google it. So there is a function that is called addPath in MATLAB, and you need to specify, so it specifies its input to the MATLAB path, but you first need to specify actually the whole path, and there's another function that's called genPath that generates a path, and we want to generate the path of print the current working directory slash SPM 12. So whenever this is of course, I'm currently copying this from the script that I have running here. It's not enough that you do that and guess what it might be doing. You might want to actually try and see what it's doing. So this, for example, does this. So this is my current path. Well, it's twice there, I'm not quite sure. So it always makes sense to check what these little things are. Why it needs this genPath for some reason. The addPath, it doesn't work without. But these are things that you learn over time, and if you have this, then you know what's going on and you can go more into details. So then we've written 2 commands in our thing here, and let's see what is doing something. Now, I think it's because then it also adds all subfolders, although it tells now something that, no, this is something else. This is import, sorry. So now we've run the script and SPM is on the path. As we see that we can analyze it based on coding it into the command line. Yeah, so then ideally we would in the very end also remove SPM from the path. So let's put that in. See how that works. So let's remove it. interesting. This has to do with that I had SPM there. It's still open. This is sometimes when you have SPM open and a program at the same time, that sometimes leads to interesting interactions. And then a good idea is always to restart SPM. MATLAB, sorry. So now we run it with add and remove, and then it doesn't move. That is there. Good. Now we have SPM on the path automatically. That's good, so we don't have to click add to path. And then you will find, if you just run SPM like this will give you a warning and ask that you initialize SPM 12 first. And jobman, this is not really necessary, but to get rid of this warning, we do it. 7219 and SPM jobman. So that is this SPM defaults FMRI. So to really understand what this is doing, you would now have to look into the SPM function and look what happens if you pass in the parameter defaults and the parameter FMRI. What this does is that it loads default parameters for FMRI data analysis. So these are stored somewhere in the SPM toolbox, and they are then loaded into the workspace so that they are available for all the SPM scripts. Things like, for example, things that actually are then also filled in the SPM editor. And then there's this jobman in this initialization, which it always wants. Where you call SPM jobman with its initial configuration. Yeah. So this is just these two things. They are not really crucial, but you get always the warning by SPM that it wants first run, please run this, and then, well, because you do what people tell you, and if your cats tell you they need food now, then you give them food. And if MATLAB tells you you have to do this, you also do. You have to do everything that people tell you. So, and that actually takes a little bit of time. That's the same thing, the time that SPM takes to initialize itself. As you can see, it's still busy. And then it's done. Function import. This is actually a function in the SPM toolbox. And oh no, is it this one? Maybe let's get. No, we need this. Sorry, forget about this. Maybe we get rid of this warning later on. Good. So this is the initialization. And that's then a good time for a break, I would say, until 11, unless there are any questions for now. No? Good. Then let's have a break.